Hello, this video is the kind of like the solution to the practice exam I gave you last week. So, all right, let's take a look at the first question. So, identify the shape of each of the four histograms below. So, yes, because we dealt with the histogram a lot, right? So that's why one of the application for histogram is just tell us the shape or distribution. So the trick to do this kind of question, you just think of, for example, like the first one, y is skewed to the left, because think about you just draw a curve on the top of the bends, right? That's kind of like this kind of shape. Okay, so this is skewed to the left, and then this is by model. Why is by model? Because you think about this one, right? There are two humps. Okay, this is by model. And then for this one, this is the unimodel and the symmetric, right? Because this is kind of like we're talking about a lot, like a bear-shaped curve. And then this is skewed to the right. Okay. So, all right. For the second question about the twin survey. All right. So for this kind of question, I just tell you how the whole process should be look like. And also, yes, with this little data set, we can answer some questions. First of all, we got to specify what is the population and what is the sample. So the population here, say, is the twin population in the areas around the ski resort. In the sample, because we sampled 10 twins, right, surveyed in the study. Of course, this study is observational. It's not experimental. It is not experiment. All right. Among these four variables, right? Then we could easily specify it as, first of all, as categorical and numerical. So obviously Q1 and Q2 are what? Categorical. Q3 and Q4 are numerical. But in terms of the ordinal and nominal, so for the categorical, right, because Q1 is about what? Just about the names of the radio stations, right? So they're just categories, no order at all. So that's nominal. But think about the rate for the quantity of the food. So we have 4 and 2 and 3. They have orders. They're not just 4 categories. That 4 means good, and right, 4 means excellent. 1 means poor. So it has an order. That's ordinal. And then for the Q3 and Q4, we need to specify, for the numerical variables, we need to specify whether discrete or continuous. So in this case, both should be continuous, okay? Right, some of you may say, why this Q3 is also continuous? Because, what time do you think it should be closed? So this time, yes, because could be any number, right? Could be a decimal. For example, if you put, you cannot just argue, say, yeah, because this time point still, we could think of hourly. You could say, yes, 1 hour, 2 hour, but it's also possible to be between, right? That's what I mean by continuous. All right. And this is the part I need to explain a little bit, okay? So for the frequency, the reason for this class, I put it right here, one as a bracket, the other one as a parenthesis. That basically means what? If there is a 10, okay, for example, actually we do have a 10, right? If we go back to the original one, do we have a 10? Yes, for example, like we have 2 10s right here. So those 2 10s shouldn't be in this category, okay? Because these 2 10s got to be the second category. So whenever there is a parenthesis, that means 10 is not included. But whenever there is a bracket, that means that point is included. This is exactly what we mean by half close, half open interval. So in the mathematics, that's exactly what we mean by that. Okay, have close CLOSE, right? So for example, like the first one, what are those two? You see, let's take a look, right? These two zeros are in the first category. For the 10, you can see how many things, 1, 2, 3, 4. They should be in the second class, and then plus there is a, I think there is a 15. Here you go. So that's how we get 5. And then do the same thing, you would get 3. And then the total observation is 10. Relative frequencies are just, you divide each of those frequencies by 10. So you get the sum is 1. But what do we mean by cumulative? Cumulative, is we're talking about the probability for up to that point. For example, like the first one, up to 10, right? But we do not include 10, so that's still 0.2. But here, up to 20, but do not include the 20. So you just add those two together. And then for the last one, up to 30, this is going to be the whole thing. So this is what I mean by cumulative. The best example for cumulative idea is, most of the time, if we're talking about a final exam, you always say, is the final exam cumulative or not? Okay, that's exactly what we're talking about, cumulative here. All right, and question number 3 is about box plot. And for the box plot, we know this is a graphical description of 5 numbers. What are the 5 numbers here? A should be what? Q1. C should be what? Q2. E should be what? Q3. Sorry. I made a mistake. Okay, this is not Q1. Okay, this should be minimum number. Okay, minimum. And this is Q1. B is Q1. C is Q2. E is Q3. And then this guy, this whisker, if there is no outlier, because this is outlier. So in this case, outlier is the max, right? Biggest number. If there is no outlier, this one should be max. But now in our case, because since there is a outlier, so this is the second max, the second largest number. Okay. All right. And then based on the graph above, what is the overall shape of the house value distribution? Here is the key, right? You based on the box plot, you should eyeball a curve like what we did in question number 1 as the histogram. So in this case, you could just do like this, right? Okay, so this obviously the shape is skewed to the right. Now put the box in the scale. Excuse me. Now let's take a look at the details of the question number A. What is A? Yes, skewed to the right. That's overall shape. Now let's put it in the scale, right? Okay, take a look. So are there any outliers in the data set? Yes, because G is the outlier. Okay, and then what's the median house value? So median is C. And what is IQR? IQR basically Q1 minus Q3, right? Q3 minus Q1. So in our case, is E minus B. Okay. And among the 7 values of A to G, A, B, C, D, E, F, G, the 7 values, which one is most possible to be the mean house value of the US 50 states and why? So we know C is median. Okay. And the only 2 possibilities for the central tendency is going to be what? gotta be either C or D. But we already know C is the median. Then D is definitely got to be the mean, because you could not use A. A is the smallest number. G is the largest number. F is the second largest number, and E is the what? Third quantile. So the only thing left now is D. And obviously, if this shape is skewed to the right, we know the mean usually is what? Bigger than median. Okay, so D is what? Is the mean. All right, now let's take a look at the question number 4. So question number 4 is about a very good example of the brand names and age groups. So the key question here, we want to know whether there is a relationship between the brand name and the age group. So most of the practice, right, we know there is a relationship, right? Because that's exactly, if you are working as a business analytics, you're going to do what? You're going to rely on this kind of relationship to decide your market practice, Okay, so this you just got it right here. Okay, so yes, and this question shouldn't be that hard, as long as you finish this guy first, right? And then just calculate the corresponding probabilities accordingly here, okay? So yes, the only thing I want to say something is about question number 4, right? What is the probability a customer is younger than 35 years old, and there's a clear indicator for what? Intersection, okay? And if you're talking about question number 5, part 5, so why do we, yes, use the union? Because of what? This or is a clear indicator for union. And then given is a clear indicator for what? Conditional, okay? This vertical bar. And to tell whether these two events are independent or not, we could use this one, right? Or we could use this one. This is by the conditional probability definition. This is by the multiplication rule. But of course, there's another one which you could say probability B1 equals the probability B1 given A. But in this case, you have to calculate the new probabilities, because if we use the first two, we do not need to calculate any new probabilities, right? Because we have this guy, we have PA and PB1, and then we just verify it. And then we have the PA, we have the what? PA given B1, okay? We just calculate. Yeah, this one works also, but you have to do an extra calculation. All right, that's now let's back to question 5. So question 5, interested in the relationship between two variables, x and y. Of course, obviously these are two what? Numerical variables. So here I just want you to practice about what we mean by a correlation coefficient, right? So given the information above, what is the sample size of the data set? So the sample size is tied to what? We have 3 observations, so n equals 3. Fill the empty cells of the table with approximate numbers. Okay, so yes, for the sum, you add those 3 numbers together equals 0, and then you add those 3 numbers, you get what? 12. And for the other ones, we could find the x bar of y, x, right? The mean of x, and the y bar mean of y. So to find the mean of x, you add those 3 numbers together divided by 3, so which you end up with 0. And then you add those 3, you get 12 divided by 3, you get what? You get 4. So basically it's 12 divided by 3, okay? And then you have x bar and the y bar equals 3, and x bar is 0, and the y bar is what? 4, you do it what? Like this case, 6 minus 0, right? You square it, you get a 36. 0 minus 0 is still 0, square this 0. Negative 6 minus 0 is still what? Negative 6, you square it, you get 36. The same thing for y, you see. 6 minus 4, right here, equals 2, square it, you got a 4. And then 0 minus 4, which is negative 4, you square it, you get a 16. 6 minus 4 is 2. 2 squared, you get a 4. And then we add those three numbers together, you get a 72. Those three numbers together, you get a 24. All right. How we're gonna get the cross product? Cross product means what? Your x minus x bar times y minus y bar. So in the first row, your 6 minus 0, which is still 6. Okay. And then 6 minus 4, which is 2. That's how you get a 12. And then 0 minus 0 is still 0, but 0 minus 4 is negative 4. But you multiply 0 with a number, which is always 0. And negative 6 minus 0 is negative 6. And 6 minus 4 is 2. Negative 6 times 2, which is negative 12. So you add together, you end up with 0. Okay. Now, based on the completed table, we calculate what is the S. Because S is the standard deviation of X, right? So we have to calculate the variance of X. Variance of X by the formula is going to be 1 over n minus 1. Here is n minus 1. And then the squared deviation, that's exactly what? Right here, this 72. That's how we get a 36. And then take a square root of 36. That's how you get what? Standard deviation. The same thing for y. 1 over n minus 1, and then the squared deviation for y is 24 right here. That's how you get 12. And then you square it, you get a 2 times square root of 3. Okay. And for the correlation coefficient, we already got the sy and sx, sx and xy. And then the only thing we need to get to what? The top terms, which is the summed cross products, which exactly 0 here. Okay. So this one looks like a complicated, but it ends up with what? 0. It's a very simple number. So, and the last one asks you to interpret how to interpret this 0. Here you're going to be very careful. Okay, so we can only say there is no linear relationship, right? Because we know correlation coefficient, this R, X, Y, only measures the linear relationship. Whenever it's 0, that means there is no linear relationship. You cannot say there is no relationship, right? Because here, obviously, as I explained in the lecture, these two numbers have what? Relationship, right? For example, like you can obviously say y equals x absolute value, right? They are related, but this relationship is not linear relationship. Okay, it's a non-linear relationship. So that's why I say if you do not specify this linear, 1 point should be deducted in the real exam. Okay, and the last question. So this is about a lie detector test. This is exactly tied to that 2x2 contingency table. We talk about a lot. Of course, in the lecture notes, we talked about the so-called diagnostic test. But here, you could think about this lie detector is like a diagnostic test, right? Test whether the person lies or not. Okay, so the first one, we need to specify this tree diagram, okay? This guy right here. All right, so this is the origin. Think about a person goes to the test, right? And then from the wording part, we say assume that 99% of the individuals who go in for a polygraph test tells the truth. So T here means tells the truth, right? Individual is telling the truth. D means what? The polygraph detects a lie. Okay, so for any individual person goes to a test, she has 99% chance to tell the truth. That's why I put 0.99 there. And then she has 1% to lie. Okay, right? All right. Now, if the person tells the truth, could the lie detector detect the truth immediately? Most of the time, if yes, that's exactly the what the lie detector is about, right? But somehow the lie detector could make mistake. That's exactly what we mean by this guy. 0.5% chance the test erroneously detects a lie even though the individual is telling the truth. So that's the probability to the person is telling the truth, but the lie detector says, okay, you're lying. But fortunately, this probability is very low, right? It's only like 0.5%, which is 0.005, okay? And then 1 minus that is going to be what? 0.995 is going to be whenever the person is telling the truth, the lie detector does not detect a lie, okay? So the same thing for if the person if the person lies right here, does not tell the truth, then what is the chance? That's exactly of what I mean by the reliability of the lie detector, right? So the lie detector will what? 95% chance that the test will detect a lie whenever the person tells the lie. That's why we put a 0.95 here. And then 1 minus 0.95, you get a 0.05. Okay, as we explained in the probability tree diagram, so the joint probability is gonna be what? The two probabilities on the route, right? Use 0.99 times 0.005, you get this guy. And then the same thing, you got this guy right here, right? And then this one, and then this one. Now you finished the whole so-called tree diagram. All right. After you finish the tree diagram, then let's move to the last part. Okay, so here, yes, this is always a pain, because we need to translate this kind of wording into what? Into this kind of probability terms. Okay, because we know T means what? Tells the truth. An individual tells the truth. D means what? The lie detector detects a lie, right? Take a look. Given an individual has just taken a polygraph test, right? What is the probability the individual was actually telling the truth? So I think here is a typo, okay? So given, this is a clear indicator for what? For conditional probability. So whenever we're talking about conditional probability, we got to be careful what is the condition. Okay, so here condition is what? Is given individual has just take a polygraph test and the lie detector has detected a lie. So that's say D is the what? Condition. Okay, the lie detector has detected a lie. And then what is the probability the individual was actually telling the truth? That's why we want to know the probability of T given D. Okay, yes, here shouldn't be intersection, should be what? Condition, okay? By the definition, we know this conditional probability is going to be intersection probability over what? These two, actually this equals what? The probability of D, right? That's how we just plug in the numbers from the probability tree. We get this guy here. Okay. I hope this video helps you a little bit about the practice exam. And if you have any questions, please let me know. Good luck. Bye.